So today we're going to be talking about lesson 5, which is on molar volume. Molar volume comes from Avogadro's hypothesis, which we're going to explain more later, but basically it states that any gas at standard temperature, which is 0 degrees Celsius, and standard pressure, which is 1 atmosphere, will contain the same number of molecules at the same volume. This volume that's set for everything is 22.4 liters. So there's this conversion here of 1 mole is equal to 22.4 liters for that conversion. This is really important that it's at STP, which stands for standard temperature and standard pressure. So we have to be at those two to have this parameter. So 1 mole of any gas at STP is going to have a volume of 22.4 liters, regardless of what the gas is. That's very common for all of them. Okay? So it's just very important, and the most common mistake students can make in using this conversion for any volume conversions, it has to be for gases at STP. Okay? So also, one thing to watch out for is diatomics. When we talk about different gases, there's 7 of them that are diatomic, so you need to make sure you're using N2, not just N. So here we have 2 examples here. So the first one here is sample of oxygen gas has a volume of 2.5 liters at STP. How many grams of O2 are present? So we're going to go ahead and work that one out together here. So we have a sample of oxygen gas with a volume of 2.5 liters at STP. So we're going to start with our known, which is 2.50 liters. Okay, so 2.5 liters, and we're going to use that conversion factor of 1 mole equals 22.4 liters. So, like we've been working on, you want to put it so that the units will cancel. So if we have liters up here and liters down here, the units are going to cancel. We get rid of the liters. And this conversion factor here is 22.4 liters is equal to 1 mole. So the 1 mole is going to go on the top there. Okay? So you're going to go ahead and calculate this out. So if you look on your calculator here, we have 2.5 divided by 22.4. This is essentially what you're doing, because remember, you multiply these, divide by this, you're going to get 0.112 moles. Okay? So that would be the answer for that first one there. You're looking for 0.112 moles. The second one says 54.3 grams of carbon dioxide occupies what volume? So first step here for the second one, you have to first decide the molar mass of carbon dioxide. So the molar mass, abbreviated MM here, the molar mass of carbon dioxide, we need to add that up from the periodic table. So carbon dioxide is CO2. Carbon has a molar mass of 12.01. And we would add 2 times 16 for oxygen. Okay? So the molar mass of carbon dioxide is 44.01. Okay, so now that we have this, we're going to start out with our known value for the problem, 54.3 grams. Okay? Now that we know that there's this many grams in a mole, this is similar to what we've been doing in the past unit here. We want to write it out so our grams cancel. Then the next step that we need to do here is we need to take the new conversion from today, which is 1 mole, is 22.4 liters. So what you end up doing is multiplying 54.3 times 22.4 and dividing by 44.01. So when you do that on your calculator, you should get 27.64. Okay, so that would be your final answer for that problem there. Alright, now, we've practiced some of those. Now we're going to move on to kind of these multi-step conversions, which is similar to this we just did here. There's more than one step involved. This first problem here, we need to decide how many liters of carbon dioxide are there in 3.9 moles of gas at STP. So we see that we have STP, so we can use this conversion of 22.4 and 1 mole. So we already figured out the molar mass of carbon dioxide for that last problem, so that's convenient. We already have that ready to go. So the molar mass of carbon dioxide, once again, is 44.01. To start this problem, use the number you're given in the problem. So 3.9 moles is what we were given. This one we actually don't even need this value for, but we did have it in case we were given a grams value to start. So this first part here, what we need to do is take the 3.9 moles. Since it's already in moles, we don't need this. So 3.9 moles. Use the conversion that we learned today, so 1 mole, 22.4 liters. Alright, so you're going to essentially multiply the 22.4 times 3.9. Okay, so make sure your units will cancel. We'll have their moles cancel there. You should get 87.4 liters. Okay. Now, if we look at the second one here, number 2, how many liters are there in 14.5 grams of hydrogen gas at STP? What's really important is that hydrogen is a diatomic. So since it's a diatomic, you need to look for this reminder here that it's H2, it's a diatomic. So the molar mass of this is 2.02. So 2 times 1.01, which is the mass of each hydrogen. So the first thing we need to start out with is 14.5 grams. And we know that we have 2.02 grams in 1 mole. Now, we need to decide how many liters are there. So we're going to use the conversion right here that we learned today. 1 mole is 22.4 liters. So we're going to go ahead and calculate 14.5 times 22.4. And divide that by 2.02. You should get 160.8. And then that's in liters. That's this last unit we have here. Okay? Now, here's some additional problems to practice. Some of these involve using the 6.02 times 10 to the 23rd number, which would be the first one and the second one. And then the third one, 156 grams of nitrogen on this slide here, is very similar to this problem. So go ahead and give these a try. And then the homework assignment that will be assigned tonight is Part B, 14 to 16, and Part C, all of them. So go ahead and give those a try and ask me any questions if you have them.